Go on. Okay, exponential decay is 8.2. Very similar to the exponential growth 8.1. The functions, what makes it a growth or decay depends on the b. So exponential decay function is of the form f of x equals a bx, so just like it was on 8.1, but now a is still going to be greater than 0, but b is going to be between 0 and 1. So in order for it to be a decay function, the base is going to be a fraction. So numbers between 0 and 1 are going to be fractions. Okay? So if it's greater than 1, it's like a fraction of 3/2, then that would not be a decay function because that's not between 0 and 1. Okay? Now we have the growth factor on 8.1, we're going to have the decay factor on this. That model is y equals a times 1 minus r to the t power. On the growth factor is 1 plus r. Okay, so we're going to be a fraction as the base when it's decay, and we're going to be 1 minus r in my decay factor model. Okay? The graphing is pretty much the same. And when you graph these functions, just pick 2 or 3 x's, figure out what the asymptote is going to be, and curve it into the asymptote. For a, we've got y equals 2 times 1/3 to the x power. So if I pick 0, what's 1/3 to the 0th power? 1. 1. 1 times 2? 2. 2. So we have a point 0.02. If x is 1, 1/3 to the first power would be 1/3 times 2 would be 2/3. So we've got 1 and 2/3. And what's the asymptote on this going to be? 0. So this line is going to curve into the x-axis like so. Okay. The second one is -3 to 3/4 the x power. If x is 0, 3/4 the 0th power is 1. 1 times -3. -3. So we've got 0, -3. And x is 1, 3/4 to the first power would be 3/4 times -3 would be -9/4, which is negative what, 2 1/4? Right there. And what's the asymptote on this one? 0. Just curve it like that. Okay, so very similar to what we did on the 8.1. Just pick a couple x's. Plug in there.
So to find the asymptote,
That's going to happen. What, to find the asymptote?
Yeah.
It's that plus k that was hanging on the end. Remember the minus h is plus k. So if there's a number added or subtracted on the end of it, then it'll be
a different number.
yeah, it'll be the asymptote. Yeah. So there's no number, then it's going to turn into
Okay.
okay. Okay. Example 2 is going to be just like it was on 8.1, where we're going to translate points from an easier function. So the function we're going to graph here is y equals 3, 1/6 to the x plus 3 minus 2. Then state the domain and the range. So Dylan, what's the asymptote going to be on this one?
Whatever x is minus 3.
It's going to be this number that's hanging on the end, -2. So the graph is going to curve into y equals -2. Okay? All right, so begin by lightly sketching this graph. So it's easier, again, to get points without the +3 and the -2. So I'm not going to sketch the graph, I'm just going to put 2 points on, and then we'll translate the graph with the -h and the plus k. So what is 1/6 to the 0th power? 1. 1 times 3? 3. So we've got 0, 3. And then 1/6 to the first power would be 1/6, and 1/6 times 3 would be 3/6, or 1/2. Okay, so 1 and 1/2. Okay, now we're not really getting to -2. Let's pick another one. If x is 2, what would that be? 2/6. So what's that's 3 over? It'd be 1 over 36. So 3 over 36 is 1/12. So yeah, we are curving into there pretty good. Okay, so there's my points on this function. Well, that's not the function we're graphing, but I can use those points, and then the h and the K. I can translate those points over for, to get the graph of this. Okay, so if it's minus H and plus K. Okay, so what is H? It's -3 because it's always the opposite of whatever H is. So I'm going to move 3 units to the left because H is -3. And what is K? It's -2. Okay, so on every point that's on this, I'm going to go 3 to the left and 2 down. So 1, 2, 3, 1, 2. And then 1, 2, 3, 1, 2. And this is going to curve into y equals -2. And again, that's not absolutely necessary to do this translating. You can just put points right into X and do the arithmetic and find those points, knowing that it goes into, curves into -2. But that's a choice you have. You can find the easier points with this and then translate them, or you can just find points directly with that function. Okay? And I don't care how you do it. You're going to get, if you do it correctly, you're going to get that graph. All right. We have a checkpoint here. It says graph y equals -2/5 to the x minus 2 and plus 2. Okay, so I'm going to go ahead and translate it. That's what the book is suggesting, so that's what I'm going to do. If x is 0, what's that going to give me? And we're going to do the that part of it. So if x is 0, -1, right? Because 2/5 of 0 power would be 1, the opposite would be -1. Okay, so 0, -1 is here. And then if x is 1, what would that be? -2/5. So 1 and -2/5. Now what's this one curving into?
Positive 0.
You know, these points are curving into 0, right? So we're here. Let's put -1 in there. So it gives another point to see if it's going flat or if it's going to go straight down. If x is -1, again, we're using this. What's 2/5 to the -1? 5/2. It flips it, and that makes that -5/2. So -5/2. So that's -2.5. So -1, -2.5 would be here. So it is preventing that down pretty good now. All right, so if we translate that, what's h and what's k?
Positive 2.
Positive 2, positive 2. So we're going to go to the right 2 and up 2. So from this point, we're going to go right 2, up 2. We're going to go 1, 2, 1, 2. And we can go 1, 2, 1, 2. And what's this one supposed to curve into?
Positive 2.
Positive 2. Is it doing that? Okay. So questions on the graph? All right. Okay, modeling exponential decay. Says a company buys a piece of machinery for $2,500. The value Y of the machine decreases by 10% each year. A, write an exponential decay model for the value of the machine. Use the model to estimate the value after 3 years. Graph the model. Use the graph to estimate when the value will be $2,000. All right, so this is our exponential decay model. Okay, so what's A in this case?
2,500.
2,500, that's the original amount. So 2,500. And then 1 minus, what's R? 0.1, yeah, 10%. And then we're going to just go ahead and put the 3 years on that. So that's going to be 2,500. And then 1 minus 0.1 is 0.9 to the third power. Okay? So if you plug that in, it comes out to be, after 3 years, the machine's worth 1822.50. Okay, so after 3 years, it's depreciating 10% a year. That's a pretty big chunk, right? Now, how come we can't just take 10% off? What's 10% of 2,500? 250, right? Why can't we just, after 3 years, why can't we just take 250 off, 250 off, 250 off? Yeah, so it's not always 10% of this, it's 10% of what it is the next year, right? So after 1 year, it's going to be 2250, and then 10% of 2250, and then so on and so forth. And that's why you use this model rather than just subtracting that chunk off the same. And if you were to graph this, it's the same as graphing before, just pick years and plug them in. After 0 years, it was worth 2,500. We first got it. After 1 year, it would be 2,500 times 0.9 to the first power. And see, I'm just cheating a little bit. The graph looks something like this. So you can figure out, okay, when is it worth 2,000? So 2,000's here. Looks like after about 2 years. Okay, and my graph's not completely accurate, but that's what they want you to do, is pick some points, make a graph, and then find 2,000 and figure out what year that would be. Okay? Questions on that? That's it. That's all the notes. Okay.
Good job, Mr. Jones.
Thank you, Andrew Miller.